lesson for algebra lesson 5.2 is using intercepts, and we're going to be talking specifically about how we use those to graph lines and to find our x and y intercepts. Our objectives are to find x and y intercepts and interpret their meanings, and then use x and y intercepts to graph lines. Our vocabulary is pretty simple. It's a y-intercept and an x-intercept. So the y-intercept represents the coordinate, or the point on where the graph crosses your y-axis. When a line crosses the y-axis, it's important to know that the x-coordinate is always going to be 0. The x-intercept is the x-coordinate where it's going to cross the x-axis, and again, the y-coordinate will always be 0 when that happens. As you can see in the graph there to the right, the x-intercept is 4, and it represents that 4, 0 is going to be the point where that line crosses the x-axis. The y-intercept is negative 120, and again, it represents where it's going to cross the y-axis and where x equals 0. So if I want to identify and label my axis here, I'm going to look at where it crosses each of the axis on the coordinate grid. So in this case, I have at 1, get my pen here, I have at 0, 1, a point, and that represents my y-intercept, because my x is 0 and my y is 1. And then I have negative 2, 0, and that represents my x-intercept. So when we're looking at graphs, all we're doing is looking for where are they crossing the x and y intercept, or the x and y axis, I'm sorry. Here we can see if I start at the origin, 1, 2, 3, so I have x is 0, y has to be 3, and for my x-intercept, I start at 0 and I count backwards, so because it's going to the left, it's negative 2, and my y-intercept is going to be 0. So negative 2, 0 for my x-intercept. How do we find the x and y intercepts in an equation? Okay, we're going to do things two different ways. Number one is we can go ahead and whenever the letter that we're solving for, our x or our y, we can just go ahead and plug a 0 into that opposite coordinate. So 5 times 0 minus 2y equals 10. If we go ahead and plug that 0 in, what we'll see here is we have 5 times 0, which is going to automatically equal 0, minus the 2y equals 10. And we're going to solve this just like we've solved equations in the past. Divide both sides by negative 2, and we're left with y equals negative 5. So when x is 0, y equals negative 5, and that becomes our y-intercept. We're going to do the same thing here to solve for x. 5x minus 2 times 0, and we're going to get 5x minus 0 equals 10. So 5x equals 10. We're going to solve for x by dividing both sides by 5. We get x equals 2. So our x-intercept is 2, 0, and our y-intercept is 0, negative 5. That's one method of doing it. Another method is we could just cover up. So if I look at our original equation, and I take something like this, and I'm just going to use that, and let me give it a little fill color here. And I just cover that up, and what I'm left with is a simple 5y equals 30, something that we can solve rather quickly. So we're covering up our x and just solving for y. Divide both sides by 5, and we get y equals 6. So when x is 0, y equals 6. And I can use the same cover-up method, and if I were to this, and we'll move it down here. But if I were to take my box and move it over the y now, and I want to solve for x, I'm left with negative 3x equals 30. And I'm doing the same thing that I was doing before. I'm going to divide both sides by negative 3 and get x equals negative 10. So when x is negative 10, we know that y is 0. So those are our two intercepts. Our x-intercept, negative 10, 0, and our y-intercept of 0, 6. What I'd like you to do for class tomorrow is these two problems. One is looking at it in terms of solving for x and y to get our intercepts and then graph the line. You can just do a quick sketch. The other is looking at the function here and then solving for your x and your y intercepts to identify what it represents. So if you can have those two completed for class tomorrow, that would be great.